my name's Thanom and I'm from UNSW. Today I'm going to work through some of the calculus problems from MATH1011, section 1.2 on absolute values. This question 6 looks quite intimidating. How large should n be in terms of epsilon for this inequality here to be true? Now, if this wasn't an inequality and it was equals, the question would really be, what is n in terms of epsilon? In other words, make n the subject. So that's what the question is really, but it's phrased how large should n be just because it's an inequality as opposed to an equals here. So I want to make n the subject here. So we would need to do a bit of simplifying. 1 is n plus 2 over n plus 2. I'm trying to make a common denominator here. So this is n minus, in brackets, n plus 2 on the numerator, which is n minus a 2. So this is minus 2 on n plus 2 here. Now, that's the absolute value of minus 2 on the absolute value of n plus 2 is less than epsilon. The absolute value of minus 2 is 2. Now, the absolute value of n plus 2 is n plus 2, but only because the question told us that n was a positive integer there. So we have 2 on n plus 2 is less than epsilon, and we need to make n the subject here. At the very least, we've simplified the inside of that absolute value, and we've managed to get rid of the absolute values. So, moving over here, that gives us 2 is less than epsilon n plus 2. I can multiply both sides by n plus 2 because without worrying about flipping the sign, because again n's a positive integer. So since n is a positive integer, so we can do that, not flip the sign because that's true. Now, I do want to divide by epsilon here. Now, epsilon is positive, right? So we won't have to flip the sign, but let's make a note of it. The only reason that's true is for this first inequality, the initial question to even be true, epsilon has to be a positive number. Absolute values are positive. They can't be less than negative numbers, right? So note for the inequality to be true, so this one, n on n plus 2 minus 1, epsilon must be greater than 0. So absolute values are greater or equal to 0, so it has to be positive. It takes a little bit of thinking to see why it can't be equal to 0 as well, but that's true too. So I can divide by epsilon without worrying about flipping the sign, because if I go back to the very original question, for that to be true, epsilon has to be positive. Now, just to make n the subject, we subtract 2. So 2 on epsilon minus 2 is less than n. That is, n is greater than 2 on epsilon minus 2. So we started with this absolute value inequality, we simplified, and we've ended up making n the subject. We just had to make some careful notes here to make sure we didn't have to flip any signs because things were negative. So hence, for this absolute value inequality to be true, n must be greater than 2 on epsilon minus 2. So there is our answer. Now, this actually has much more meaning beyond just making n the subject here. And it's to do with the formal definition of a limit, which if you do MATH1131, you will study a little bit about. So this is actually talking about the distance between a function and its limit being less than any epsilon you like, and working out what value of n in terms of epsilon that will be true for.